Okay, review 5 starts off with properties of exponents, and the thing about these is there's more than one way to do them. But if you look at number 1, you're going to notice that there is an exponent outside of the parentheses, so we're going to want to take care of that first. So we're going to take this -2 and distribute it to each exponent at the bottom. So this is going to turn into x to the -4th and then y to the +2nd. The top, I'm just going to kind of leave it alone for now. And then what I want to do is I want to fix all my negatives. So that means that my x's, they're going to have to switch. So I'm going to go ahead and put the x to the 4th up and the x to the -1 down. And when they switch, the sign changes. And I'll go ahead and leave my y's alone since they're positive. So now what we can do is we can subtract the exponents from top to bottom. I think of it as canceling. So if I have 4 x's on top and 1 on the bottom, that's going to leave me with 3 x's on top. So I'm going to have x to the 3rd on top. If I have 3 y's on top and 2 on the bottom, 2 of them should cancel with 2 on top. So that's going to leave me with 1 y. That's my final answer. Problem 2, we can go ahead and simplify this by fixing all of the negatives. So I'll leave the 20 alone for now. And this is going to become x to the 7th, y to the 5th. And this is going to be 5, x to the 3rd, and then y. So now that I have everything positive, I can go ahead and start attacking this problem. So the 20 over 5, we just divide that like normal. So 20 divided by 5 is 4. So that's going to be on top because 20 is bigger. If I have x to the 7 on top and x to the 3rd on the bottom, I can subtract those. And that's going to leave me with 4. And then I can subtract these. Don't forget this has a 1 on it. So 5 take away 1 is 4. And everything ends up on top because there's more on top. That's our final answer. Okay, the next one, it's got 2 things to it. So that just means that we can combine stuff that's on the same level. So I'm going to go ahead and do that. So I'm going to create one fraction with everything. So the 2 is going to stay on top. There's 2 x's on top, so I can add these together when they're at the same level. So that's going to be x squared because 3 plus -1 is 2. And I'm going to leave my y to the -3rd up there. And then at the bottom, I'm going to have a 6. And then I'm going to have an x to the -2. And then I'm going to have a y squared. The next thing I like to do is take care of all my negatives. So I'm going to switch some stuff around. So I'm going to leave everything else where it's at that's not negative. So I'm going to leave 2x squared on top. That y to the -3rd is going to have to go to the bottom and become y to the 3rd. This x to the -2nd needs to come up and become x to the +2nd. And then I'm going to leave the 6 here. And then there was also the y squared down at the bottom. So now, if you have letters that are at the same level, either both on top or both on the bottom, they just add. So we can also take care of the 2 over 6. That just reduces like a regular fraction. So that's 1/3. And then we're going to have x to the 4th on top. And then at the bottom, we're going to have y to the 5th because we just have to add the exponents whenever they're being multiplied. This 1 out in front isn't really necessary, but you can write it if you want to. Okay, number 4. Number 4 is a little tricky because you have to make sure that you work on the exponent on the outside first. So what we're going to do is we're going to take this 3 and multiply it to all 3 exponents on the inside. Now I said 3 because there's a 1 on this 3 right here. And the rule is to multiply the exponents together. So we can't multiply the 3 with the base of 3, but we can multiply 3 with its exponent of 1. So this first part is going to become 3 to the 3rd, x to the 6th, y to the 9th. And we can leave that in parentheses if we want. I'm going to leave these alone for now. So 6x to the 5th and y squared. So what I want to do is I want to simplify all of my numbers that have exponents. So that's going to be 27, x to the 6th, y to the 9th. And then I have 6x to the 5th, y squared here. So what I want to do now is I just want to multiply the 6 times the 27. And we're multiplying these because they're not the same base. So that's going to give us 162. The x's, since we have repeating bases like that, we want to add the exponents together. So we're going to have x to the 11th. And then we're going to have y to the 11th as well. That's my final answer. Okay, learning target 2 is operations with polynomials. So what we want to do here is add, subtract, and multiply. So we're going to go ahead and start off by adding. When we add, there's a +1 out in front. So basically this clears your parentheses, because when you multiply everything by 1, nothing happens. Both of these have a positive 1, so nothing's going to happen to any of them. So I'm going to just bring this stuff down without the parentheses. And then what I want to do is start to combine like terms. Now, since we want to put the answer in order, we want to start with the highest exponent. So I'm going to start with these guys. This is a 1x to the third plus 3x to the third, so that's 4x to the third. And remember, when you're adding, you just add the numbers in front and then reattach the letter. The next one should be the x squared, and that's the only x squared in the question, so I'm going to bring that down. Then we're going to put together the x's, x to the first. That's the only x to the first, so I'm going to bring that one down. And then last, I'm going to put the constants together. So there's a constant here and a constant here. And if you notice how I circled those, the signs are attached to the numbers. So whatever sign is right before it, that's the sign of that number. So -8 plus 5 ends up being -3, and that's our final answer. So when we do problem 6 down below, problem 6 is very similar, except this one actually has a -1 right here. You're going to have to be real careful with that, because when you multiply something by -1, every sign flips. So this is going to be -5x squared minus 12x plus 6. The first one isn't really going to change because it has a +1. So when you times the +1 to everything, it stays exactly the same. And then after we combine, after we get rid of all of our parentheses, now we can combine like terms starting with the x squareds. So I have a +3x and a -5, so that means -2x squared. Then I have a -9x and a -12x, so that makes -21x. And then I have my constants, +3 and +6 makes +9. So that's my final answer. So the next one is multiply, and you can tell it's multiply because these two parentheses are touching. So when we have to multiply, we just have to distribute. So we're going to take this 2 and multiply it to all three of those terms. So 2x times x squared gives us x to the third, because you have to add up the exponents. 2x times x is plus 2x squared. And then 2x times -4 is -8x. Then what we're going to do is we're going to take the second term, the -3, and distribute it as well. Now you can continue to write the answer going across, but I like to line up my like terms because I'm going to have to put them together anyways. So if I do this -3 times x squared, that's -3x squared. If I do -3 times x, that's -3x. And then -3 times -4 is +12. So now I could just put these together. When I combine my like terms, I'm going to have 2x to the third minus x squared, or you can put -1x squared, it's the same thing, minus 11x plus 12. That's our final answer. Okay, the next one is a division problem. You can do this a couple of different ways. If you want, you can use the long way, or you can use synthetic division. Synthetic division only works when this is x to the first power and there's a 1 in front. So what we're going to do is I'm going to use synthetic division since it's a lot faster. So synthetic division takes the 2, the 7, the -6, and the -8. So we're basically doing the coefficients and the constant. Then when you take the term from the x plus 4, it has to be the opposite number. First one drops down, so that's a 2. And then we're going to multiply that with the -4, so that's -8. When we combine those, we're going to get a -1. When we multiply that back to the -4, that's going to give us a +4. Then this is going to give us a -2 when we combine -6 plus 4. And then multiply the -2 times this -4, so that gives us +8. -8, +8 gives us 0. So now the only thing we have to do is we have to put the letters back on. So if the original problem started off as x to the third, doing synthetic division one time will lower the exponent by 1. So this is going to become 2x squared minus x minus 2, and then this would be the remainder, but the remainder is 0, so we don't have to write anything. So that's our final answer. Okay, the next one says, write the polynomial that represents the area. When we talk about the area of something, the area of any box is going to be the base times the height. So all we have to do is we have to take the 2x minus 1, which is the base, and multiply it times the height. So we're going to have to distribute this, so that's 2x squared. Distribute that, and we're going to get plus 6x. Then we're going to have to take the -1 and distribute it, so that's -1x, and then -1 times 3 is -3. Then we have to combine like terms. These two go together, so that's going to give me 5x. And then we have 2x squared, and then minus 3. And if there was units on this, I don't see any units anywhere, it would be units squared, like feet squared or yards squared or whatever it is. Okay, so the next one says, according to the remainder theorem, if you calculate f of c equals 0, what does that tell you about x minus c and the polynomial? So this one is pretty much just a memorizing thing. Anytime you get an answer of 0, that means that the x minus c is a factor of the polynomial. If this was a different number besides 0, then it's not a factor. Okay, the next question says, for each of the following, use the remainder theorem to evaluate. So we have to basically plug it in. If it gives us a number, that number is going to be the remainder. If it gives us a 0, then it's going to be a factor. So in the calculator, we're going to want to do this. So we're going to take all of the x's out and use parentheses in their place, and then minus 20. So what I'm going to do is I'm going to take my calculator and I'm going to plug all 3 values in. And through movie magic, there's our 3 answers. So when we plug in 4, it gives us negative 103. So that right there is the remainder. And when we plug in 0, that gives us negative 20. So that's the remainder. And when we plug in 0, there is no remainder. So it says, what conclusion can be made from the results of 15? The only one that's going to be a factor is going to be x plus 2 is a factor. Remember that the only time you get it as a factor is when it gives you an answer of 0. And then when you use this number, you have to remember to always change the sign. Okay, next it says x plus 5 is a factor. So if it is a factor, that means that we can use our synthetic division to lower the exponent. So I'm going to use a negative 5 here. And this is going to be 1, 2, negative 33, and negative 90. Now, because it is a factor, this last number right here is going to end up being a 0. So let's do the work. So we're going to bring down the 1. So that's 1. 1 times negative 5 is negative 5. Combine those, and that's negative 3. Combine those, and that's 15. And then we're going to have, what is that? Positive 15 and negative 33 is negative 18. And then when we multiply negative 18 times negative 5, that gives us 90. So that's going to actually be the 0 that we were talking about before. Now, we knew that was going to happen because that's what it means to be a factor. So now what we're going to do is we can actually put the x's back on. So this would be x squared minus 3x minus 18. And because this is a simple ABC, we can use one of our factoring methods to factor this. So we need to find 2 numbers that multiply to 18 but combine to the middle number. That's going to be 3 and 6. And then what we're going to do is we're going to make it so it gives us a negative 3. So that would have to be a minus 6 and a plus 3. Now that it's factored, we can take each factor and set it equal to 0 and solve it. So I'll subtract 3 to both sides. So one of them is going to be negative 3. And then I can add 6 to both sides. And the other one is going to be positive 6. So it says, ooh, I should have read the directions. It says find all other factors. So the other factors are these guys. These are the factors. And these right here are the zeros. So you got to make sure that you read the directions. Okay, next one. Very similar. Again, now this time it says find all of the other factors. So I'm not going to make that mistake and do extra work. So I'm going to take positive 1. And then I'm going to do 2, 1, negative 2, and negative 1. If it's a factor, it's guaranteed that this last number is going to be 0. So watch what happens. We're going to bring this down. That's a 2. 2 times 1 is 2. And then we're going to combine those, and that's a 3. 3 times 1 is 3. Combine those, and that's 1. 1 times 1 is positive 1, and there's our 0. So this guy right here, this ends up being 2x squared plus 3x plus 1. Now this guy right here, this is a complex ABC, and the reason why it's complex is because of this 2. So we're going to have to multiply that with the 1. So we're going to have x squared plus 3x plus 2. And now we can treat this almost like a simple ABC. So in a simple ABC, we just have to find the factors of 2 that add to 3. So that's going to be 1 and 2. Now, everything is going to be positive here because positive 1 times positive 2 multiplies to positive 2, and then 1 plus 2 adds up to 3. The fact that this was not a simple ABC, though, we can't just ignore the fact that we took out this 2, so we're going to have to divide this by 2 and divide this by 2. If it divides, you divide it. So this is going to be x plus 1. And if it can't divide or simplify, then you take the bottom number and you move it up. So this is going to be 2x plus 1 in those parentheses, and these are the other 2 factors. Okay, number 19 says, what is the minimum degree of a function that has 4 real zeros? So there is a connection between the number of answers, this means 4 answers, and the exponent. So the minimum degree would have to be 4. So our problem would say x to the 4th, blah, 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 blah. But the answer is just 4. Okay, this one says, what are the zeros of the function? Well, this one's nice because it's already been factored for us. So all we have to do is take each factor and set it equal to 0. So x minus 3 equals 0, and then x plus 4 equals 0. So I'm going to add the 1 to both sides. That gives me 1. This is going to subtract 2 to both sides. That's minus 2. That's going to add the 3 to both sides, so that's 3, and then subtract 4 to both sides, so that's minus 4. Simple. The one below it, kind of the same, except it's got a little bit more work to it. So we've got x minus 25 equals 0, and then x squared plus 16 equals 0. It's asking for the zeros, and it just doesn't say real or anything, so I've got to find them all. So I'm going to add 25 to both sides. So this is x squared equals 25, and then we're going to square root this, and that gives us 2 answers. So we're going to have plus or minus 5, and then I'm going to subtract 16 from both sides. So I have x squared equals minus 16, and then I'm going to square root this. So we talked about how to fix a negative inside of your square root. It's just going to become an I. So the square root of 16 is plus or minus 4 with an I attached to it. So since this had 2 x's and this had 2 x's, we should have a total of 4 answers. So we've got 2 here and then 2 here. See what else we got over here. Find all of the zeros from the following function. So what we need to do here is figure out the p and q stuff. So we want to set up our p over q's. So the p is 8 and the q is going to be 1. So that means when we write the factors, it's 1 and 8 or 2 and 4, and then the factors of 1 are just 1. So the possible factors of p over q are plus or minus 1, plus or minus 2, plus or minus 4, and then plus or minus 8. Now what we can do with this is we can actually plug this stuff into the calculator. And I've showed you guys multiple ways of doing things. You can either spend time plugging in the plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8, and figure out which one gives you the zeros. But we also talked about looking at it on Desmos or on the graphing calculator. So either way is fine with me. So I'm going to go ahead and substitute this into my calculator really quick. So I'm plugging in positive 1. Let's see, minus 8x squared plus x, and then minus 8. So if I go into, I just need to find 1. So I'm going to just try to find one of these answers. So it looks like one of the answers is going to be 8. So when I plug in 8, the answer is 0. So that means that I should be able to use the 8 to lower the exponent. So there's going to be 1 minus 8, 1 minus 8. So we're going to drop this down, and that's 1. So that right there is going to be 8. So that's 0. 0 times 8 is 0. So that's 1. And then 1 times 8 is 8, and that's 0. So this allows me to lower down the exponent. So let's see what we got here. So this is x squared. That would be plus 0x plus 1 equals 0. And now I'm going to have to solve this. So I'm just going to subtract 1 from both sides. So x squared equals negative 1. And then I'll square root this. So x equals plus or minus 1i. So out of this list, there was only one number that was going to work, and that was going to be the positive 8. The reason why none of these other numbers worked is because the other answers had an I on it. And obviously these don't have I's, so that's the only way you could get the other answers. Okay, the next one says find the zeros of the following functions. So this one right here is a cubic, a difference of cubes. So we're going to have to cube root each term. So if I take the cube root of x to the third, that's going to give me x. If I take the cube root of 27, that's 3. And then we're going to do x squared, multiply those together, so 3x, and then 9. So we're following the pattern. I forgot to tell you the pattern. It goes like this, a, b, and then b times b. So for the first term, it's a times a, so x times x. The second term is a times b, so x times 3 is 3x. And then the last term is b times b, which is 3 times 3. Then we just have to follow the SOAP acronym. So this is minus, plus, plus. That's our answer. Oh, we're solving it. Sorry, we're finding the zeros. Now, the only zeros that we're going to find here they come from this first parentheses. So we're going to get x equals positive 3. And that comes from setting x minus 3 equal to 0 and then solving it like normal. This one right here, usually this one right here is going to have i's in it. And we're not even going to bother with that. We're just going to find the real zeros there. Okay, and then finally, the last one, we've got to graph this. So we can find out quite a few things here just from the points that are given. So if I have x minus 4, that means that it's going to cross at positive 4. If I have x plus 3, that means it's going to cross at minus 3. And then if I have x plus 6, that means it's going to also cross at minus 6. Now this is going to be altogether, this is an x to the third. So the end behavior for an x to the third is usually down and then up. But because there's this minus, this over here is going to flip. So that means that the right side is going to point down and the left side is going to point up. Now what happens in between, I'd probably have to go into a graphing calculator or Desmos to figure that stuff out. So I'm going to go ahead and just use the graphing calculator. So I have x minus 4, parentheses, x plus 3, and then parentheses, x plus 6. So in the graphing calculator, we should be able to find, well, we have the roots already. The roots are going to be x equals negative 6, x equals negative 3, and then x equals 4. We know the end behavior. The left side points up, so that's going to be a positive infinity, and the right side points down, so that's going to be a negative infinity. The domain, it goes left forever and right forever, so that's negative infinity to infinity. And then the range is going to go down forever and up forever, so that's negative infinity to infinity as well. And then let's see what we got here. We're going to have to find the maximum and minimums in order to figure this out. So my viewing window on my calculator is not large enough, so I'm just going to make the numbers, I don't know, kind of big, just so I can find the tops and bottoms of this graph. So if I go into my viewing window, I'm going to go up to this and hit 75. So my viewing window is down on the y-axis 50 and then up on the y-axis to 100. And I'm just exaggerating. I just made big numbers so that way I can find the bottom and the top. So if I go to GSolve and go find the minimum is going to happen. Oh, this is a horrible graph, whoever made this, but it's going to shoot way down here and then come to here. And then the maximum, let's see, maximum GSolve max. The maximum is way up at 84, so it goes way up here. So I can't tell you what the max and min are, but I'm going to go ahead and pretend like I do know them. So the maximum is going to be at 1 point, let's see, what is that? Oh, we'll just call it 1.3 and 84.7. Well, we'll call it 84.8. That's going to be for this guy right here. So at 1.3, 1.3 is going to be our important spot. So that's 1.3 right there. And then our minimum, which is on the left side, this guy down here, it's way too low to be able to see it on here. So I'm going to go G solve minimum. Our minimum is going to be at negative 4.6, and we'll call this 19.3. So that means right here at negative 4.6, we're going to mark that off, negative 4.6. And then we have a negative infinity here and a positive infinity over here. So for the increasing and decreasing stuff is going to come straight off of that x-axis once we have everything labeled. So this portion here is going to be where the graph is heading down. So that's going to be decreasing from negative infinity to negative 4.6. And then the second part from negative 4.6 all the way to the next number I listed, which is 1.3. So from here to here, the graph goes up. So that's going to be the increasing, negative 4.6 all the way to 1.3. And then finally, let's see what we got here. Change the colors for you. Then from 1.3 all the way to infinity, the graph is heading down. So we're going to put a union and then 1.3 all the way to infinity. Did I do this one right? I think I wrote this one wrong. Hold on a second. No, we're good. Yeah. So that's our increasing and decreasing. Last one is average rate of change between the maximum and the minimum. That's why I wanted to write these guys down. So I'm just going to have to do y1, or was it y2 minus y1 over x2 minus x1. So it's going to be 19.3 minus 84.8. So I have this set up as y2 and y1, and then this is x2 and x1. So x2 is negative 4.6 and minus 1.3. So this can all go into the calculator. So I'm going into my regular calculator and hitting the ABC button. 19.3 minus 84.8 on the top. Oops. And then down at the bottom, we're doing negative 4.6 minus 1.3. So this answer is approximately about 11.1. And that's our final answer. So I believe that's pretty much it for the review. So hopefully this video helps. We can rock out this test. So good luck.